Okay, Calculus 1, welcome back. Um, we learned about U substitution in section 5.5. There's a million good problems to do there, and I might need to go back and do a couple more, but it runs right into section 5.7. Now, by the way, we skipped section 5.6. Our book's a little funny. 5.6 is an interesting topic about limits. It's kind of misplaced in between here. So we usually do that section up in Cal 2. You don't need an explanation of that. So we're moving into 5.7, where we do more U substitution, particularly involving this guy, which is, the integration of 1 over x equals the natural log of x. That's pretty famous. They kind of, I've already talked about it, but they kind of introduce it here in 5.7. The derivative of log x is 1 over x, so the integral of 1 over x is log x. And if you generalize that, the integral of a 1 over u du is the natural log of u. So that's, by the way, I want to point out one thing. This is what happens when you have a 1 over x. You do not do a power rule. Almost everything else, an x squared, a square root of x, you do a power rule. The power rule fails. This is not a power rule. This is a natural log function. Okay. So here's this problem. 1 over x plus 8 looks kind of a lot like that, but it's different. Technically, it's a U substitution problem. It's not a very interesting U substitution problem. Watch this. You let u equal the x plus 8. Immediately, you should find du. Du is the derivative, which is a dx. You replace all this stuff. U substitution is a replacement game. This turns into 1 over u du. You with me on that? That's my u. My dx is a du, and then that's the natural log of u. So this is the natural log, absolute value of u. I'm going to go ahead and put the x plus 8 in there, and this problem's over. So sometimes U substitution is rather trivial, as opposed to this problem. Okay, now watch this one. This was a little different. This time it has a 2 in the numerator. That's not a big deal. The 2 just comes out. But the u would be that denominator again. I'm going to let u equal 3x minus 4. The du this time is a 3 dx. And I've tried to explain this in my previous videos here, that you divide by 3, 1/3 du is dx. And then you replace all this stuff. So when this one gets replaced, there's the 2 on top. That's a little different than this one. The 2 comes out. That's not a big deal. The denominator is a u, though. The denominator is your u, so it's 1 over u. And the dx gets replaced with what it is. And what is dx? It's a 1/3 du this time. Because of that coefficient of 3, it spits out a 1/3. I replace it with a 1/3 du. I replace it with a 1/3 du, but I always just pull the 1/3 out and put the du here. But I replaced it with what it is, 1/3 du. So this answers the natural log of u with a 2/3 out front. And it's cool to understand that. I hope you understand that. Let's do another one. Let's do another one. It's cool to contrast these. If you can get a u in the denominator, that's good. That's just natural log of u. Let's try this guy. 5x over an x squared plus 6 dx. I don't know. You could run through your brain and think about all the different options it might be, but you should let u equal the denominator. You should let u equal the denominator, x squared plus 6. What is the du? You got immediately, please find du. That's how you do U substitution. You declare something as u, and then you immediately find du. It's the derivative. It's a 2x dx. All right, now I'm happy about that. Because I was worried about how was I going to handle this extra x in the numerator. I knew that might be my u, but how was I going to handle it? But that extra x in the numerator is going to be taken care of here with the du. Now here's how I like to do it. I think of this as an x multiplied by a dx. That's what it is. That is what it is. The dx is, I told you that before, the dx is off to the side or in the numerator. And so that's an x dx. And so what is x dx? So this time what I do is I solve for x dx. I divide by the 2. 1/2 du is x dx. I'm going to replace that. The 5 comes out. The 5 comes out. The denominator is a u. And that circled x dx is 1/2 du. I pull the 1/2 out front. So that's a du over u. That's natural log of u. I didn't write it like that here. Again, I wrote it off to the side. Du, but that's 1 over u. Du is du over u. Same thing, okay? And so this, yeah, we're done. This is the natural log of u plus c with the 5/2 out front. You could say, where'd the 5 come from? Oh, it's obvious. It was right here. Where'd the 1/2 come from? That came from the u substitution. It came from the du. Wait, by the way, we don't stop there. We should plug u back in. U is, I want to show you something here. Watch this. I'm going to put x squared plus 6. Well, look what I just did. I lost my absolute value. We always have absolute value on these answers to try to keep the input of the log positive. But you know what? When it's an x squared plus 6, it's positive. It's always positive. So it's not wrong. It's just redundant to have the absolute value on there. So I took them off. Cool. There's the answer. All right. I got a few more ideas gonna go here. I'm gonna hit pause at the moment though.